we're going to be able to free up a lot of our times from the work that distracts us and be able to focus on more meaningful work.
That is the hope, yeah.
On this episode of the OpenGradient podcast, our Chief Strategy Officer Advait and our CEO Matthew discuss the future of verifiable inference, digital twins, and AI-to-AI interoperability. Stay tuned for all of that and more.
So Matthew, tell me more about why you designed the architecture for OpenGradient the way you did.
So the OpenGradient network is a blockchain network that has fundamentally reimagined how blockchains could work. The easiest way to explain it is we use node specialization. So we have these powerful GPUs and TEs designed to do things like inference, and we basically have the rest of the network, these regular blockchain nodes, that are designed to validate the work of these specialized nodes. This way, we are able to achieve a nice balance between scalability as well as decentralization, because we have few nodes that are doing a lot of the work, and we have many other nodes that are doing cheaper validation of the work from those nodes, which improves some of the security guarantees that the network has to offer.
And so how do you ensure that the workflows that the developer wants to conduct remain private?
Yeah, so there are certain models and workflows that could be run by TEs, which inherently have privacy and confidentiality guaranteed through hardware, mostly due to isolation of memory, isolation of compute, and they're able to not just have private and confidential compute, but also be able to guarantee the integrity of the compute, because these attestations that these TE nodes generate are able to prove that, hey, we are running this code, this is the image of the code that we're running, and this guarantees that people can't actually manipulate the data or manipulate the code inside the TE.
And so is this a real risk, the people manipulating the data and the code?
Yeah, definitely. We've seen many instances where different applications and providers have decided to use different models or can manipulate the data in order to reduce costs. As an example, I think there have been reports where people who are vibe coding with cursors started seeing the models reason in Chinese and things of the sort. And ultimately, I think in an age where AI agents gradually become tasked with more critical and more important decisions, it's important that they are going to do work that is of a certain quality. And part of that guarantee involves making sure that we're using the right model and the right data.
And so why shouldn't the user just trust OpenAI with their data?
I think for the most part, in general, it's not bad to trust OpenAI. I think many people choose to do so. Many applications built today directly use APIs from these centralized LLM providers. But I do think there exists a world where, especially if you have a lot of sensitive user data, you might not want that data persisting on OpenAI servers. And I think like one concern that has been raised is that technically OpenAI is a private company in the US. As such, they're subject to regulatory measures, which could involve them handing your data over to the government if the government were to subpoena them. And I think, it would probably be fine for many use cases or the majority of use cases, but certainly I think many folks want to have certain parts of their data shielded from these types of risks.
I guess it really depends from person to person which kind of data they want to share and which they consider critical. Tell us more about Twin.Fun and how is it different from any other AI agent launchpad?
Yeah, Twin.Fun is an AI agent launchpad that is designed specifically to allow users to launch AI digital replicas or clones of themselves in a super seamless and simple fashion. They can go onto Twin.Fun, connect their socials, and essentially upload some basic information about themselves, and we will pull all that data, use memsync's memory library to generate vector embeddings with that data, which has features including automatic PII redaction to ensure that your private data isn't leaked. And then we turn that directly into an AI clone of the user. And through the Launchpad, other users can buy shares or keys of the AI digital clone, and they can then interact with your twin. And we're building some more interesting features that allow these twins to interact with users in a more exciting way.
And so what you can do today is you can chat with different kinds of personalities on Twin.Fun, such as Balaji or Nawal. So how do you see Twin.Fun as a launchpad evolving, and what are the next steps beyond chat?
Yeah, so we're particularly excited about digital twins because we think that they will be fundamentally the future of how productivity operates for people. you won't be doing a lot of the work because your digital twin is able to deeply understand your work that you do and is able to do your work more effectively for you. And with that in mind, I think it's extremely important for us to continue building not just better memory, better operative features for digital twins, and also more integrations that allow the AI digital twins to do things such as invest or trade or at large. We think what's next is continued development of these AI agents to ensure that they are on the right track to increase productivity. One of the things that we're very focused on is verifiable interoperability with different protocols and agent-to-agent interactions to ensure that, again, we can have a productive agent economy where ideally every interaction is trustless and verifiable.
And so when you say interop, what do you mean?
Yeah, what I mean is agents paying each other for services and ensuring that the services are up to par. And this really encompasses a very large subset of economic activity, which could involve, as an example, if you wanted to book an airline ticket, you, instead of having to go to a website yourself to book it, you can talk to an agent, and the agent can simply navigate to different sites, find you the best price and the best flight, and then book that for you. Your digital twin will be able to understand your preferences when it comes to costs, when it comes to your airline of preference, as well as perhaps your proclivities when it comes to layovers. And digital twins, again, will be very, very impactful in the future for automating a lot of this work for people.
We're going to be able to free up a lot of our times from the work that distracts us and be able to focus on more meaningful work.
That is the hope, yeah.
And when you say that these agents will also be able to make payments to other agents, what does this new economy look like, and how can somebody who's building something in this space maximize their chances of success?
Yeah, I think first and foremost, it's important to have agents that specialize in certain services and become domain experts in services. I think ultimately the fundamental assumption of an agent-to-agent economy is that these agents will be better than humans at the majority of tasks. And we want to see more teams build agents that are hyper-efficient at specific tasks.
So hyper-specialization for the different agents is the key to success for anybody who's watching. When it comes to hyper-specialization, can you give us more of an example of what this would look like in this new economy?
As an example, this is not a well-kept secret, but if you book a flight and you VPN to India or certain countries in South America, you can actually get cheaper flights than if you were booking in the US. One way that an AI agent can have an advantage over an actual travel agent, in addition to things such as speed and efficiency, would be the power of computer programs on your side, where you can VPN into all these different countries and see which country or which airline offers the lowest prices. And that's an example of a real use case that would be better tackled by an AI agent, because they're able to source all these different flights from different sites and locations to find the best price. And we're excited to kind of see more and more of these types of agents. Talking to some of the guys from Near Foundation, I know this is actually a very active topic that they're tackling. So yeah, we're very excited to see things come to life.
I see. So on both sides, we're going to have agentic actors. So there's going to be, I guess, the travel booking agents themselves are going to employ their army of agents to try to get the maximum price out of the users, and the user is going to try to find the minimum price. So you have agents negotiating on both sides. So when these two agents debate with each other and negotiate, then what are the key things that will differentiate a winner and a loser in terms of these agents?
Yeah, no, I think that's a particularly interesting as well as a highly multidimensional problem space. I don't necessarily think there's a win or a loss here. As an example, if I'm trying to sell a sweater, I might try to price it differently depending on the region I'm trying to sell to, as well as the other products and services that might be tied to that. I can sell tiered systems with flexible warranties that are priced accurately by AI that today we don't have simply the capacity to actively price and are tailored to the needs of the user. And it suddenly becomes, again, a problem space that is very complex, because you can't just look at short-term, I guess, like greedy pricing. These are complex problems that are multidimensional, contain many different factors, and operate on many different time horizons. And I think as compute becomes more powerful for AI agents. I think they'll be able to price these things in a more flexible and dynamic way to ultimately generate more GDP and value in a more efficient way. Yeah, a lot of this is just like general thought.